right, friends. So I left you thinking about what we already knew about this problem, what we needed to find out about this problem, and how we were going to find this out, right? And so I hope that you were able to pick out the important information and realize that, wait a minute, it seems like they're trying to organize these chairs for a school play, right? And they arrange these seats or these chairs into 16 rows. So when we think of rows, right, we're thinking of this direction. Next, if they were placing 28 chairs in each row, then that kind of lets me know that I needed to figure out how many chairs there are in total by multiplying, right? And so we said when solving multi-digit multiplication problems, we are choosing a preferred strategy. So just like yesterday, I'm going to start off with my partial products, also known as the area model, right? And so let's try this out. I know because 16 is a two-digit number, I'm going to have to decompose the two digits this way. And because 28 is also a two-digit number, I'm going to have to decompose 28 this way. And so we should have a box. I'm going to try to make it nice and big for us. With two spaces for the two numbers here and two spaces for the two numbers here. Okay? Next, I think what's going to help us visualize this for some friends is possibly using colors, right? And so if I'm decomposing the number 16, I'm going to think to myself, well, what is the value of the digit 1? And so the value is, think with me, yep, 10. And now I'm going to think to myself, well, what is the value of the number 6? Well, 6 is in the ones place, and so the value is, sound of my snap, 6, right? And I'm going to do the same thing for the number 28. But please remember, friends, the way we obtained 10 and 16 is because we were able to decompose. We were able to expand the number 16. Similarly, we're going to do the same thing for number 28. Okay? And so, think of the value of the digit 2. And that should be 20. And also think of the value of the digit 8. And so because 8 is in the ones place, we're going to write 8. Okay? Now this is a part where we are going to write our individual equations in each box just to show our work and to guide our thinking a little bit more so that we're not making any mistakes and so that we can also visualize how many zeros we should include whenever we see zeros, okay? So for my first equation, remember, I'm going to line up my tens place with my tens place in my second factor. So 10 times 20 equals, kind of like to look at my tens place. 2 times 1 is 2. How many zeros? 1 and 2. So that means it is 200, right? Let's do the same thing now for our next box, okay? Again, I'm going to multiply this time 20. I'm going to multiply times 6. I'm going to think to myself, well, what is that? 20 times 6, right? Now again, 6 times 2, friends, is 12. Let's use black for this. And 6 times, how many zeros, friends? 0. All right? Just so that we see all the partial products, I'm going to make sure they're all in black so that we kind of can process this information a little bit more. All right, next, let's do the same work right over here. What equation am I going to place here in order to solve for my next partial product? Think to yourself. Give you 5 seconds. 4, 3, 2, and 1. Alrighty. So we have 10 times 8, right? Again, friends, if it helps you to use the zero strategy, go ahead. I know 8 times 1 equals 8. And then how many zeros? 1. We can also just simply think, well, 10 times 8 I also know is 80, right? Alrighty. Last but not least, what is my other partial product? So again, this time I'm going to multiply the ones here with the ones over here. And so there should be 6 times 8. Now, friends, whatever you need to do to get there, please do so. Whether you need to skip count, whether you need to recite like a common math fact and then add some, whatever you need to do, but do this work with me. 6 times 8 is, give you some thinking time, 48, okay? Now, because I have solved for all my partial products, we know that we've only solved for the bits and pieces. And in order to figure out my product, I need to now piece those partial products together, right? And we're going to do so by using addition, right? We want to figure out the sums of my partial products. Alrighty, so let's do this. I'm trying to figure out where I have the most space. I think over here is fine. So I'm going to add 200. I'm going to add 120. I'm going to add 80. And last but not least, 48. Make sure that you are able to line this up. Okay? Now, I did run out of space here. I don't know if you can tell from your viewpoint. So, just kidding. We're going to transfer this information here. Sorry, friends. Thought it looked like enough space, but I guess it didn't. All right, let's try now. Sorry. All right. Adding the ones place value, 0 plus 0 plus 0, and 8 equals 8. 10th place value, so technically the values are 20 plus 80 plus 40, right? Or we could simply just think of it as 8 plus 2, which is 10, 10 plus 4, which is 14. I need to make sure I regroup into now the hundreds place column. So again, the values are 200 plus 100 plus another 100, or we can think of it as 2 plus 1 plus 1, which equals 2, 4. Okay? So now it seems like we've derived to our answer, right? We can now say, well, wait a minute. I feel like the answer, I follow the steps, and so the answer has to be 448 chairs. However, friends, we said in order to be 100% sure of our answer, we want to make sure that we are what? Refer to your criteria for success if you need to. We're checking our work, right? And so we're going to do this today by using another operation, which I know some of us don't feel 100% comfortable with, but try to follow along with us today, all right? So tune into the second part so we can review now standard algorithm to check our work.